Tonight I want to take you somewhere extraordinary, somewhere that exists all around you right now, yet remains one of the most profound mysteries in all of science. We're going to explore something so fundamental to your existence that you probably never stop to think about it: light itself. But not in the way you might expect. You see, scientists have been discovering something rather remarkable lately, something that challenges everything we thought we knew about the nature of light. They're beginning to wonder if light might be alive in ways we can't quite understand. I know how that sounds at first. Perhaps a bit strange, maybe even impossible. Light is just electromagnetic radiation, isn't it? Just waves and particles doing what physics tells them to do. But the more we look at light, the more we study its behavior, the more it seems to whisper secrets about consciousness, information, and the very fabric of reality itself. Before we drift deeper into this mystery together, I'm curious about you. Where are you listening from tonight? What time is it where you are? Perhaps you're tucked into bed, or maybe you're settling into a comfortable chair, letting the day slowly fade away. Wherever you are, whatever time zone cradles you right now, you're part of this global community of curious minds who find comfort in exploring the universe's mysteries as we drift towards sleep. If you're enjoying this journey into the strange world of light, perhaps you'd like to follow along for more of these cosmic explorations. A gentle like or subscribe helps others find these peaceful voyages through science and wonder. But for now, just relax, settle in, and let's explore this together. What if light was not just a dry equation in a textbook, but a quiet doorway into how consciousness and matter intertwine in ways we're only beginning to glimpse? What if those photons streaming from your bedside lamp, from the stars above, from the screen you might have just turned off, what if they carry something more than just energy? Scientists are finding behaviors in light that seem almost purposeful, almost aware, and tonight we're going to gently explore what that might mean. You and I were made of atoms that were forged in the hearts of dying stars, atoms that have been bathed in light for billions of years. Every cell in your body right now is quietly humming with electromagnetic activity, producing its own faint light, a phenomenon called biophotons that scientists have only recently begun to measure. We are beings of light in a very literal sense, and perhaps that's why this question feels so compelling. When we look at light closely, really closely, at the quantum level where things get strange and beautiful, we find behaviors that don't quite fit into our simple categories of living and non-living. Consider this. Right now, as you listen to my voice, light is streaming through your room, through your windows if they're uncovered, through the very walls themselves in the form of radio waves and cosmic radiation. This light has traveled vast distances, some of it from the sun, taking 8 minutes to reach you, some from distant stars traveling for years, centuries, millennia. And here's where it gets interesting. That light seems to know things. It knows how to find the fastest path through any medium. It knows how to interfere with itself to create patterns of incredible complexity. It knows how to carry information in ways that seem to transcend the normal rules of space and time. Scientists have been observing something called quantum entanglement in photons, where two particles of light can remain mysteriously connected across any distance. Change one, and the other responds instantly, as if they share a form of awareness that transcends the space between them. It's a phenomenon that Einstein himself called spooky action at a distance, and even today, physicists struggle to explain it in terms that don't sound almost mystical. When we send light through certain experimental setups, it seems to know whether we're watching it or not, changing its behavior based on our observation. This isn't mysticism or pseudoscience. These are reproducible experiments performed in laboratories around the world. The double-slit experiment, perhaps the most famous experiment in quantum physics, shows us something extraordinary about light. When we fire photons one at a time through two slits, they create an interference pattern as if each single photon somehow goes through both slits simultaneously and interferes with itself. But the moment we try to observe which slit the photon goes through, the pattern disappears. The light seems to know we're watching and changes its behavior accordingly. How can something non-living know anything? How can it respond to observation if it has no awareness? These questions have led some scientists to propose radical ideas. Perhaps consciousness isn't something that emerges from complex arrangements of matter, but rather a fundamental feature of the universe itself, with light playing a special role as a carrier or medium of this cosmic awareness. It sounds like science fiction, but serious physicists are publishing papers on these ideas in peer-reviewed journals. They're calling it panpsychism or cosmopsychism, the idea that consciousness might be a basic feature of reality, like mass or charge. Dr. Gregory Matloff, a physicist at New York City College of Technology, has proposed that stars might possess a form of consciousness, using light as their means of perception and communication. He points to the strange movements of certain stars that seem to defy our models, unless we consider the possibility that they might be making choices. It's a controversial idea, certainly, but it's being discussed seriously in academic circles. The fact that we're even having these conversations shows how mysterious light remains, even after centuries of study. Think about bioluminescence for a moment, the ability of certain living creatures to produce light. Fireflies dancing in summer evenings, deep-sea creatures creating their own stars in the absolute darkness of ocean trenches, even some mushrooms glowing softly in dark forests. Life has evolved to create and manipulate light in countless ways, but what if the relationship goes deeper? What if light itself has properties that we might associate with life? The ability to process information, to respond to its environment, to maintain organized patterns against the tide of entropy. Scientists studying biophotons, the ultra-weak light emissions from living cells, have discovered that these emissions aren't random. They show patterns, coherence, and seem to play a role in cellular communication. Fritz Albert Popp, a German biophysicist, has spent decades documenting how living organisms emit and absorb biophotons in ways that suggest a sophisticated optical communication system within and between cells. When cells are healthy, their light emissions are coherent, organized. When they're stressed or dying, the light becomes chaotic. It's as if life and light are engaged in an intimate dance we're only beginning to understand. The more we study light at the quantum level, the more we find behaviors that challenge our definitions. Photons can exist in superposition, being in multiple states simultaneously until observed. They can tunnel through barriers that classical physics says should be impenetrable. They can become entangled, sharing information instantly across any distance. They seem to take all possible paths simultaneously, and then somehow choose the optimal one. These aren't behaviors we associate with simple, non-living particles. They hint at something more complex, more mysterious. Consider how plants use light in photosynthesis. Recent discoveries have shown that plants use quantum coherence to achieve near-perfect efficiency in converting light to chemical energy. The incoming photons seem to explore all possible pathways through the plant's photosynthetic complex simultaneously, finding the most efficient route with an accuracy that our best computers can't match. It's as if the light knows exactly where it needs to go, as if it has a purpose, a destination in mind. How can something without consciousness have purpose? Or are we perhaps too limited in how we define consciousness? Some researchers are looking at light as a form of information itself, not just a carrier of information. In this view, the entire universe might be thought of as a vast information processing system, with light as its primary messenger. The physicist John Wheeler proposed the idea of it from bit, that all physical entities are information theoretic in origin. In this framework, light isn't just moving through space, it's constantly processing and updating information about the universe. Every interaction between light and matter is a computational event, an exchange of information that shapes reality itself. The strange properties of light extend even to how it experiences time. From light's perspective, if we can speak of such a thing, time doesn't pass. Due to the effects of special relativity, a photon traveling at the speed of light experiences no time between its emission and absorption. From our perspective, a photon from a distant star might travel for millions of years before reaching your eye. But from the photon's frame of reference, the journey is instantaneous. It exists in an eternal now, connecting distant points in space and time as if they were the same location. This timeless quality of light has led some scientists and philosophers to wonder if light might be a bridge between the temporal world we experience and some deeper, timeless reality. There's something called the delayed choice quantum eraser experiment that takes these mysteries even further. In this experiment, scientists can seemingly change what happened to a photon in the past by making a choice in the present. The light seems to retroactively adjust its history based on future observations. It's as if the light exists in a state of pure potential until the entire experimental setup, including future measurements, is complete. This challenges our basic understanding of cause and effect, of the arrow of time itself. If light can respond to future events, what does that say about its nature? Is it simply following the strange rules of quantum mechanics, or is there something more going on? The electromagnetic spectrum, of which visible light is just a tiny portion, extends from radio waves longer than mountains to gamma rays smaller than atomic nuclei. All of it is light, just at different frequencies, and all of it shows these same mysterious quantum properties. Your body right now is swimming in an ocean of electromagnetic radiation, radio waves from distant galaxies, microwaves from the cosmic background radiation left over from the Big Bang, infrared from every warm object around you, and yes, those mysterious biophotons from your own living cells. You're not just bathed in light, you're participating in a vast electromagnetic conversation that spans the universe. Scientists have discovered that many animals can see or sense parts of the electromagnetic spectrum that we can't. Birds navigate using the Earth's magnetic field, possibly through quantum entanglement in certain proteins in their eyes. Bees see in ultraviolet, revealing patterns on flowers invisible to us. Some snakes detect infrared, seeing heat signatures in total darkness. Mantis shrimp have the most complex eyes known to science, seeing types of polarized light we can barely imagine. Each species has evolved to perceive different aspects of light's nature, different slices of this electromagnetic reality. What might we be missing? What properties of light remain hidden from our limited senses? The connection between light and life goes back to the very beginning. The first life forms on Earth were likely photosynthetic bacteria, learning to capture and use light's energy billions of years ago. This innovation changed everything, filling the atmosphere with oxygen and enabling the explosion of complex life. In a very real sense, we are all children of light, descendants of organisms that learn to dance with photons. Every breath you take is possible because ancient bacteria figured out how to split water molecules using the energy of sunlight. Every beat of your heart is powered by chemical processes that trace back to photosynthesis. But what if the connection goes even deeper? Lynn Margulis, the biologist who revolutionized our understanding of cell evolution, suggested that life might be a natural consequence of light interacting with matter under the right conditions. In this view, life isn't a lucky accident but an inevitable result of the laws of physics, laws in which light plays a central role. The same quantum properties that make light so mysterious might be essential for life itself. Quantum coherence in photosynthesis, quantum tunneling in enzyme reactions, possibly even quantum processes in consciousness. Life seems to exploit the strange properties of the quantum world, properties most apparent in light. Stuart Hameroff and Roger Penrose have proposed that consciousness might arise from quantum processes in microtubules within neurons. These tiny structures might act as quantum computers, processing information in ways that classical physics can't explain. And what might be the medium of this quantum computation? Possibly biophotons, the light within our cells. While this theory remains controversial, it's being seriously investigated. Scientists have detected biophoton emissions that correlate with neural activity, suggesting that our thoughts might literally shine, that consciousness might involve the generation and processing of light at the cellular level. There's an old philosophical question. If a tree falls in a forest and no one hears it, does it make a sound? Quantum physics suggests an even stranger question. If a photon travels through space and is never absorbed, did it ever really exist? Light seems to require interaction, observation, relationship to fully manifest its reality. It exists in a state of potential until it encounters matter, until it's observed, until it completes its journey. This interdependence between light and observation, between electromagnetic radiation and consciousness, hints at a universe far more interconnected than we usually imagine. The behavior of light in living systems shows remarkable coherence and organization. While thermal radiation from non-living objects is random and chaotic, the biophotons from living cells show patterns, rhythms, and coherence that suggest information processing. Some scientists have proposed that these biophoton fields might act as a kind of holographic information system within organisms, coordinating cellular activities and maintaining the organized complexity we call life. Death, in this view, might be understood as the collapse of this coherent light field, the dissolution of the electromagnetic patterns that maintain biological organization. When we look at the role of light in ecosystems, we see networks of extraordinary complexity. Sunlight drives photosynthesis in plants, which feed herbivores, which feed carnivores, with energy flowing through the food web. But there are also more subtle exchanges. The biophotons emitted by one organism might influence others nearby. Plants have been shown to respond to the light emissions from neighboring plants, even emissions too weak for us to detect without sensitive equipment. Forest ecologists speak of the wood wide web, the fungal networks that connect trees, but perhaps there's also a web of light, a photonic communication system we're only beginning to discover. The question of whether light is alive might be the wrong question entirely. Perhaps the boundary between living and non-living isn't as clear as we thought. Perhaps consciousness, awareness, information processing, qualities we associate with life, exist on a spectrum throughout nature, with light playing a fundamental role in this continuum. The universe might be more alive than we imagine, not in the biological sense, but in some deeper, more fundamental way that we don't yet have words to describe. Scientists studying the origin of life have discovered that certain minerals can organize light in ways that concentrate energy and catalyze chemical reactions. Clay crystals, for instance, contemplate the formation of organic molecules when exposed to light. Some researchers propose that life might have begun in the interaction between light and mineral surfaces, with the first metabolic cycles driven by photochemistry on crystal faces. In this scenario, the organization of light by non-living matter gradually gave rise to the self-organizing systems we call life. The boundary between living and non-living becomes blurred when we look closely at these transitions. There's a phenomenon called weak quantum measurement that allows scientists to gently probe quantum systems without fully collapsing their wave functions. Using these techniques, researchers have observed that photons seem to gradually transition between quantum and classical states, rather than suddenly choosing when observed. It's as if the light is constantly feeling out its environment, gathering information, and adjusting its behavior accordingly. This gradual responsive transition looks less like the behavior of a simple particle, and more like something processing information, something aware of its surroundings in a primitive way. The study of quantum biology is revealing that many of life's essential processes depend on quantum effects that were thought impossible in warm, wet, noisy biological systems. Enzymes use quantum tunneling to speed up chemical reactions. The sense of smell might involve quantum vibrations. Bird navigation might use quantum entanglement. And in all these processes, electromagnetic fields, light in its various forms, play crucial roles. Life hasn't just adapted to use classical properties of light. It has evolved to exploit the deepest, strangest aspects of quantum mechanics, suggesting an intimate relationship between consciousness and the quantum properties of light. When we look at the universe on the largest scales, we see that light connects everything. Every atom that absorbs and emits photons is in communication with the rest of the cosmos. The cosmic microwave background radiation, the afterglow of the Big Bang, bathes every point in space with ancient light that carries information about the universe's birth. Starlight carries information about the chemical composition, temperature, and motion of distant suns. The light reflected from planets tells us about their atmospheres, their surfaces, their potential for life. The universe is engaged in a vast conversation mediated by light, and we are just beginning to learn how to listen. Some cosmologists have proposed that the universe itself might be thought of as a vast quantum computer, processing information through the interaction of light and matter. In this view, every photon is a bit of cosmic information, every interaction a calculation in the universe's ongoing computation of itself. The laws of physics might be understood as the universe's operating system, with light as its primary means of information transfer. This isn't just metaphor. Serious scientists are working out the mathematics of this idea, trying to understand reality as information processing on a cosmic scale. The mysteries deepen when we consider dark matter and dark energy, which together make up about 95% of the universe, but don't seem to interact with light at all. Or do they? Some theories propose that dark matter might interact with regular matter through exotic forms of light, dark photons that we haven't yet detected. The universe might be filled with forms of light we can't see, carrying information we can't access, connecting parts of reality that remain hidden from us. Our entire understanding of light might be like understanding ocean waves while being unaware of the deep currents below. There's something called the anthropic principle that observes how precisely the laws of physics seem tuned for the existence of light, matter, and life. If the electromagnetic force were slightly stronger or weaker, atoms couldn't form. If the speed of light were different, the universe would look nothing like what we observe. Some scientists see this as evidence of a multiverse, with countless universes where the laws are different and light behaves differently. But others wonder if there's a deeper reason why the universe seems so perfectly configured for the dance between light and matter that makes our existence possible. When we study black holes, we find places where light itself becomes trapped, where the fabric of space-time curves so severely that even photons can't escape. Yet Stephen Hawking showed that black holes must emit radiation, a faint glow caused by quantum effects at the event horizon. This Hawking radiation suggests that even in the most extreme conditions in the universe, light finds a way to emerge. Information that falls into a black hole might be preserved in this radiation, encoded in the subtle patterns of escaping light. The universe seems determined to preserve information, to maintain the conservation of light even in the face of gravitational collapse. The phenomenon of sonoluminescence shows us another strange face of light. When tiny bubbles in water collapse under sound waves, they produce flashes of light so brief and intense that the temperature momentarily reaches that of the sun's surface. How can sound create light? The mechanism isn't fully understood, but it seems to involve the conversion of mechanical energy into electromagnetic radiation through processes that push our understanding of physics. It's another reminder that light emerges from matter in ways we don't fully comprehend, that the boundary between mechanical and electromagnetic phenomena isn't as clear as our textbooks suggest. Scientists have recently discovered that certain materials can slow light down to walking speed, or even stop it completely, storing it in the material and then releasing it later. This stopped light maintains all its quantum properties, including entanglement. It's as if the light pauses, waits, then continues on its journey. During this pause, is the light still light, or has it become something else? A pattern in matter that remembers being light and can become light again. These experiments challenge our basic understanding of what light is, suggesting it might be more like a pattern or process than a thing. The study of metamaterials has revealed that we can create substances with optical properties that don't exist in nature. Materials with negative refractive indices that bend light backward. Materials that can cloak objects by guiding light around them. Materials that can trap and concentrate light in ways that seemed impossible just decades ago. We're learning to sculpt the flow of light, to choreograph its dance with matter in new ways. As we do, we're discovering that the relationship between light and matter is far more flexible than we imagined. Matter isn't just a passive recipient of light. It can actively shape and transform light's behavior in ways that blur the distinction between the two. There's a deep connection between light and information that becomes apparent in quantum computing. Quantum computers using photons as qubits can perform calculations that would take classical computers longer than the age of the universe. The light in these machines isn't just carrying information, it's processing it in ways that exploit quantum superposition and entanglement. A single photon can explore multiple computational paths simultaneously, as if it has a kind of quantum awareness of all possibilities. These machines hint at the computational potential inherent in light itself, suggesting that every interaction between photons might be a kind of calculation, a processing of cosmic information. The phenomenon of quantum teleportation, despite its science fiction name, is very real and has been demonstrated with photons over distances of hundreds of kilometers. In this process, the complete quantum state of one photon is transferred to another distant photon, with the original photon being destroyed in the process. It's not the photon itself that travels, but its information, its quantum identity. This suggests that what we call a photon might be better understood as a pattern of information that can move from one electromagnetic excitation to another. Light might be less about particles or waves and more about information structures that propagate through the quantum field. When we look at how the brain processes visual information, we find layers of mystery. The eye converts light into electrical signals, but somewhere in the brain, these signals become conscious experience. The redness of red, the brightness of a summer day. How does the brain transform electromagnetic information into subjective experience? Some neuroscientists propose quantum processes in the brain that might directly interface with light at the quantum level. Others suggest that consciousness might involve biophoton emissions within neural tissue, creating an internal light that somehow generates awareness. We don't know, but the fact that light becomes experience in consciousness suggests a deep connection we don't yet understand. The study of circadian rhythms reveals how deeply light is woven into the fabric of life. Every cell in your body has molecular clocks that synchronize with the daily cycle of light and darkness. Exposure to light at night disrupts these rhythms and has been linked to numerous health problems. It's as if our bodies expect a certain conversation with light, a daily exchange that has shaped our evolution for billions of years. When we interfere with this ancient dialogue between life and light, our health suffers. We are creatures of light in ways that go far beyond vision, with every aspect of our biology tuned to the rhythms of electromagnetic radiation. There's something called the quantum Zeno effect, where observing a quantum system frequently enough can freeze its evolution. Shine enough light on certain quantum processes, and they stop changing. It's as if the light holds the system in place through the act of observation. This has profound implications for how we think about the role of observation in quantum mechanics. Is the light simply revealing what's there, or is it actively participating in determining what becomes real? The boundary between observation and creation becomes blurred when we look closely at how light interacts with quantum systems. Scientists have discovered that water has a kind of memory for light exposure, maintaining structural changes for significant periods after illumination. The molecules in water exposed to certain frequencies of light organize differently than unexposed water, and these differences can persist. Given that our bodies are mostly water, this raises intriguing questions about how light exposure might influence our biology in ways we haven't yet measured. Every glass of water you drink has been shaped by its history of light exposure, carrying patterns that might influence how it interacts with your cells. The phenomenon of lasing, light amplification by stimulated emission of radiation, shows us how light can organize itself into coherent beams of extraordinary intensity and precision. In a laser, photons stimulate atoms to emit identical photons, creating a cascade of perfectly synchronized light. It's a kind of light organizing light, creating order from chaos through a process that looks almost like cooperation. Natural lasers have been discovered in space, in the atmospheres of Mars and Venus, suggesting that this self-organizing property of light operates throughout the cosmos. When we examine fossil records, we find evidence that life has been responding to and shaping light for billions of years. Stromatolites, structures created by ancient photosynthetic bacteria, show us that life was organizing around light from its earliest days. The evolution of eyes has happened independently dozens of times, suggesting that detecting and processing light is one of life's most fundamental drives. Even creatures in the deepest ocean trenches, where sunlight never reaches, have evolved to create and detect bioluminescent light. Life seems compelled to engage with light wherever it exists, as if drawn by some deep affinity. The study of quantum chromodynamics, the theory of the strong force that holds atomic nuclei together, reveals that even the forces between particles can be understood in terms of exchanging virtual photons, temporary fluctuations of light that pop into and out of existence. In this view, all forces in nature except gravity are mediated by various forms of light. The entire structure of matter, the stability of atoms, the chemistry that makes life possible, all of it depends on the constant exchange of these virtual photons. We exist because light, in its various forms, is constantly flickering in and out of existence, maintaining the patterns we call matter. There's a beautiful phenomenon called crown flash, where light appears to dance and spiral above thunderclouds, creating patterns that look almost organic, almost alive. Scientists believe it's caused by changing electric fields, aligning ice crystals in the clouds, which then reflects sunlight in shifting patterns. But watching these displays, it's hard not to see something that looks purposeful, intentional, as if the light itself is performing a dance. Throughout nature, we find these moments where light behaves in ways that seem to transcend simple physics, creating patterns of such beauty and complexity that they challenge our assumptions about the boundary between living and non-living phenomena. Recent experiments with twisted light, photons carrying orbital angular momentum, have revealed that light can carry vastly more information than previously thought. A single photon can be encoded with enormous amounts of data in its quantum properties. Some researchers suggest that biological systems might use these properties. that the biophotons in our cells might carry far more information than simple intensity or wavelength would suggest. The light within living systems might be a rich information network we're only beginning to discover, a quantum internet operating within every organism. The discovery of quantum criticality in biological systems suggests that life operates at the edge between order and chaos, in a regime where quantum effects can influence macroscopic behavior. Light plays a crucial role in maintaining these critical states. The energy from photons keeps biological systems poised at this edge, where they're maximally sensitive to information and capable of rapid adaptation. Too much order, and the system freezes. Too much chaos, and it dissolves. Light provides just the right input to keep life dancing at the edge of possibility. When we look at how plants communicate through volatile organic compounds, we're seeing another face of the electromagnetic spectrum at work. These molecules absorb and emit light in the infrared range, creating a kind of chemical optical communication network. A plant under attack by insects releases compounds that not only repel the attackers, but also signal to neighboring plants and attract predators of the insects. This communication happens through molecules that are essentially conducting electromagnetic conversations. The forest is filled with invisible light, carrying messages we're only beginning to decipher. The phenomenon of superradiance shows us how atoms can cooperate to emit light more efficiently than they could individually. When atoms are close enough together and properly aligned, they can emit photons in a coordinated burst that's faster and brighter than normal emission. It's as if the atoms are working together, synchronizing their light production in a way that looks almost intentional. This cooperative behavior in light emission has been observed in biological systems, suggesting that life has evolved to take advantage of these quantum cooperative effects. Scientists studying extremophiles, organisms that live in conditions that would kill most life, have discovered that many of them have unique relationships with light. Some bacteria can use infrared radiation from deep-sea thermal vents for a kind of photosynthesis in total darkness. Others have evolved proteins that can detect single photons, achieving the theoretical limit of light sensitivity. These organisms show us that life finds ways to engage with every form of light available, pushing the boundaries of what we thought possible. Wherever there's electromagnetic radiation, life finds a way to use it, to dance with it, to make it part of its story. The mystery of ball lightning, rare spheres of light that float through the air during thunderstorms, remains unsolved despite centuries of observations. These glowing orbs behave in ways that seem almost lifelike, moving against the wind, passing through walls, maintaining stable structures for seconds or minutes before disappearing. Some theories propose they're plasma structures, others suggest they're quantum phenomena, but no one really knows. They remind us that even familiar forms of light can behave in ways we don't understand, exhibiting properties that challenge our categories of natural phenomena. When we study the quantum vacuum, what we call empty space, we find it's actually seething with virtual photons constantly appearing and disappearing. This quantum foam of light creates measurable effects, like the Casimir force that pulls parallel plates together in a vacuum. Empty space is full of light we can't see, a constant flickering of electromagnetic potential that might play a role in everything from the stability of atoms to the expansion of the universe. The void is alive with light in a very literal sense, and we are just beginning to understand what this means. The development of optogenetics, where neurons are genetically modified to respond to light, has revolutionized neuroscience. Scientists can now control brain activity with extraordinary precision using pulses of light. But this technology also reveals something profound. Our neurons, the very cells that generate our thoughts and consciousness, can be made to dance to light's rhythm. It suggests that the relationship between consciousness and light might be more direct than we imagined. Perhaps our brains are already optical computers of a sort, using biophotons in ways we haven't yet discovered. There's a phenomenon in quantum optics called squeezed light, where the uncertainty in one property of light is reduced below the normal quantum limit at the expense of increased uncertainty in another property. This squeezed light can be used to make measurements more precise than classical physics allows. Recent research suggests that biological systems might produce and use squeezed light, particularly in photosynthesis, and possibly in neural processing. Life might be squeezing light, manipulating its quantum properties in sophisticated ways that we're only beginning to understand. The study of metamaterials has led to the creation of time crystals, structures that repeat in time rather than space. When these time crystals interact with light, they can create photons that seem to violate conservation of energy, at least temporarily. It's another reminder that our understanding of light is far from complete. The normal rules we learned in physics class are just approximations of a deeper, stranger reality where light can behave in ways that seem impossible. When we look at the role of melanin in biological systems, we see another face of life's relationship with light. Melanin doesn't just absorb light to protect us from UV radiation. It might also conduct electricity, process information, and even perform a kind of primitive photosynthesis. Some researchers propose that melanin was one of the first biological polymers, helping early life forms harness light's energy. This dark pigment that colors our skin, hair, and eyes might be one of life's oldest technologies for engaging with light, a molecular machine that bridges the gap between electromagnetic radiation and biological process. The discovery of photonic crystals in butterfly wings, peacock feathers, and opal gemstones shows us that nature has been engineering light at the nanoscale for millions of years. These structures manipulate light through their periodic patterns, creating colors without pigments, controlling the flow of photons with architectural precision. The brilliant blue of a morpho butterfly's wing isn't from any blue pigment, it's from microscopic structures that interfere with light waves. Life has evolved to be an architect of light, building structures at the scale of wavelengths to create the visual world we experience. Scientists have recently discovered that certain quantum properties of light, like entanglement and coherence, can survive in biological systems at body temperature for much longer than physics predicted. The warm, wet, noisy environment of living cells should destroy these delicate quantum states almost instantly. But somehow life has evolved ways to protect and use them. This suggests that quantum properties of light might be essential for life, not just incidental. We might be quantum beings in ways we're only beginning to understand, with light as the medium of our quantum nature. The phenomenon of autofluorescence, where biological tissues naturally glow when exposed to certain wavelengths of light, is revealing hidden patterns in living systems. Every type of tissue has its own fluorescent signature, its own way of transforming absorbed light into emitted light. Doctors are beginning to use this natural fluorescence to detect diseases, as cancer cells glow differently than healthy cells. It's as if each cell type has its own conversation with light, its own dialect in the electromagnetic language. Disease might be understood as a disruption in this conversation, a breakdown in the cell's ability to properly engage with light. When we examine the fossil record, we find evidence that major evolutionary transitions often coincided with changes in light availability. The Cambrian explosion, when complex animal life suddenly diversified, happened shortly after the atmosphere became transparent enough for sunlight to penetrate deep into the ocean. The evolution of flight allowed organisms to follow light into new niches. The development of photosynthesis transformed the entire planet's chemistry. At every crucial juncture in life's history, light has been there, shaping possibilities, driving innovation, creating new ways for matter to organize itself. The study of cosmic rays, high-energy photons and particles from space, reveals that we're constantly bombarded by light from across the universe. Some of these cosmic rays come from supernova explosions millions of light-years away. They pass through your body right now, occasionally causing mutations in DNA that might drive evolution. In this way, light from distant cosmic events directly influences life on Earth, writing messages into our genetic code. We are not isolated on this planet. We're in constant communication with the cosmos through light. There's a hypothesis called the light switch theory of consciousness, proposing that awareness might emerge when biophoton emissions in the brain reach a certain threshold of coherence. Below this threshold, there's neural activity but no subjective experience. Above it, the light within our neurons creates a field of awareness. While speculative, this theory is driving research into the optical properties of neural tissue. Scientists are discovering that neurons might act as optical waveguides, channeling biophotons in ways that could support quantum information processing. The discovery that DNA can conduct electricity and emit light has profound implications. The molecule that carries our genetic information isn't just a passive storage medium, it's electromagnetically active. When DNA is damaged, its light emissions change. Some researchers propose that DNA might use light to communicate between cells, coordinating activities across tissues. The genetic code might be just one level of information, There might be an electromagnetic code as well, written in the language of biophotons. When we study how birds navigate using Earth's magnetic field, we find quantum entanglement at work. Special proteins in birds' eyes seem to use entangled electrons to detect magnetic fields, essentially seeing magnetism through quantum properties of light-activated chemical reactions. It's navigation by quantum compass, using the strange properties of light and matter at the smallest scales to find direction across continents. If birds are using quantum mechanics to navigate, what other quantum processes might be hiding in plain sight in living systems? The phenomenon of phosphorescence, where materials continue to glow after light exposure ends, shows us that matter can store and slowly release light over time. Some organisms have evolved to use this property, creating a kind of biological battery that stores solar energy as excited electrons and releases it slowly as light. It's another way that life has learned to manipulate light, to bend it to biological purposes. These glowing organisms remind us that the boundary between light and matter is more fluid than we might think. Scientists studying the deep ocean have discovered that even in the absolute darkness of ocean trenches, life creates light. An estimated 90% of deep-sea organisms below 500 meters are bioluminescent. In the absence of sunlight, life creates its own light, its own visual world. This isn't just for seeing. Bioluminescence is used for communication, defense, hunting, and mating. The deep ocean is a world of living light, a testament to life's deep connection with electromagnetic radiation. Even where the sun never shines, life insists on light. The discovery of quantum tunneling in enzyme reactions reveals that life operates using the strangest aspects of quantum mechanics. Enzymes speed up chemical reactions by allowing particles to tunnel through energy barriers rather than going over them, a quantum shortcut that makes life's chemistry possible. Light often triggers these reactions, providing the energy for quantum tunneling to occur. Without these quantum effects, the chemical reactions necessary for life would be too slow. We exist because light enables matter to take quantum shortcuts, to break the rules of classical chemistry. There's something called the photothermal effect, where certain nanoparticles can convert light into heat with extraordinary efficiency. Researchers are discovering that biological systems use similar mechanisms. Melanin, for instance, might not just absorb light but convert it into useful forms of energy for cells. Some bacteria have evolved photosynthetic systems that work in the infrared range, essentially using heat as a form of light. The boundaries between light, heat, and biological energy are more complex than our textbooks suggest. When we look at the phenomenon of crown shyness, where tree canopies avoid touching each other, leaving gaps that create beautiful patterns when viewed from below, we see another possible role for light in biological organization. Trees might be detecting light reflected from neighboring trees and adjusting their growth accordingly. The forest canopy becomes a kind of photonic computer, processing information about light availability and competition, creating patterns that maximize light capture for the community. It's cooperation through light, a vegetative social network mediated by photons, the study of quantum dots, tiny semiconductor particles that emit light when excited, has revealed that similar structures exist in biological systems. Some bacteria produce quantum dots that might help them perform photosynthesis or detect light. These biological quantum dots could be processing information at the quantum level, using light in ways we don't yet understand. Life might be doing nanotechnology with light that surpasses our best engineering efforts. Scientists have discovered that the human body emits ultra-weak photon emissions that follow circadian rhythms and respond to our mental and emotional states. When we're stressed, our biophoton emissions become more chaotic. When we're healthy and calm, they show more coherence. Meditation has been shown to affect these emissions. It's as if our inner state is written in light, broadcast in a language we're only beginning to learn to read. Perhaps ancient traditions that speak of auras and inner light were detecting something real, something that modern instruments can now measure. The phenomenon of magnetic reconnection in space, where magnetic field lines break and reconnect, releasing enormous amounts of energy as light, might have analogues in biological systems. The electromagnetic fields around cells are constantly shifting, and when they reorganize, they might release biophotons. This could be a mechanism for cellular communication or energy distribution. The same physics that creates solar flares might be operating at a microscopic scale in our bodies. When we study how certain crystals can split single photons into entangled pairs, we find a process that might occur in biological systems. Some proteins have crystal-like structures that could create entangled photons. If biological systems are creating and using entangled light, it would revolutionize our understanding of how life processes information. Quantum entanglement in biology isn't just theoretical anymore. It's been observed in photosynthesis and might be far more widespread than we imagine. The discovery that some organisms can detect and respond to single photons, the absolute minimum unit of light, shows us that life has evolved to the physical limits of light detection. The human eye, under ideal conditions, can detect single photons, though we're not consciously aware of it. Some deep-sea fish have evolved eyes so sensitive they can see by the light of bioluminescence from miles away. Life pushes against the boundaries of what's physically possible, extracting information from the faintest whispers of light. There's a phenomenon called electromagnetically induced transparency, where materials that normally absorb light can be made transparent by applying another light field. Recent research suggests that biological systems might use similar effects. Cells might be able to control their transparency to certain wavelengths, creating optical channels for biophoton communication. Your body might be more optically active than you imagine, with cells controlling the flow of light in sophisticated ways. The study of plasmonics, where light interacts with electrons in metals to create waves of electron density, is revealing that biological molecules might use plasmonic effects. DNA, proteins, and other biological structures might be amplifying and focusing light at the nanoscale, using principles we're just discovering. Life might be doing photonics at the molecular level, manipulating light in ways that our best technology is only beginning to achieve. When we examine how fireflies synchronize their flashing in certain species, we see a kind of distributed optical computing. Thousands of individual insects coordinate their light production without any central controller, creating waves of light that pulse through forests. It's self-organization through light, a kind of optical intelligence that emerges from simple rules and optical feedback. These displays remind us that light can be a medium for collective behavior, for the emergence of patterns larger than any individual participant. The discovery of topological insulators, materials that conduct electricity on their surface but not in their interior, has led to proposals that similar structures might exist in biological systems. These could create protected channels for biophoton transmission, quantum highways for light within cells. If such structures exist in biology, they would provide a mechanism for maintaining quantum coherence in the warm, noisy environment of living tissue. Scientists studying photosynthesis have discovered that plants might be performing a kind of quantum computing, using superposition to explore all possible paths for energy transfer simultaneously. This isn't metaphorical, it's literal quantum computation using light. The efficiency of photosynthesis approaches theoretical limits that can only be achieved through quantum effects. Every leaf is a quantum computer, processing light in ways that our most advanced technology struggles to replicate. The phenomenon of optical binding, where particles can be trapped and organized by light fields, shows us another way light can create structure from chaos. Scientists can use laser light to assemble nanoparticles into complex patterns, essentially using light as a construction tool. Similar processes might occur in biological systems, with biophoton fields organizing molecular structures. Light might not just illuminate life, it might actively participate in building and maintaining biological structures. When we look at the role of light in embryonic development, we find mysteries we're only beginning to explore. Developing embryos emit specific patterns of biophotons that change as organs form. These light emissions might be carrying information that helps coordinate development, ensuring that cells differentiate properly and organs form in the right places. The blueprint for life might be written, not just in DNA, but in patterns of light that guide development from a single cell to a complex organism. The study of metamaterials with negative refractive indices has shown us that we can make light behave in ways that seem to violate our intuitions about physics. Light can be made to bend backward, to create perfect lenses without aberration, to flow around objects as if they weren't there. Nature might have discovered similar tricks long before we did. Some biological structures might be manipulating light in ways that seem impossible according to classical optics. There's a quantum biological hypothesis that consciousness might involve light confined in microtubules acting as quantum optical fibers. These protein structures in neurons could support coherent biophoton states that process information in ways that create subjective experience. While controversial, this theory is driving research into the optical properties of neural tissue. We might be beings of light in a much more literal sense than we ever imagined. The discovery that certain bacteria can use quantum coherence to transfer energy with near-perfect efficiency, even in noisy, room-temperature environments, has overturned decades of assumptions about quantum mechanics. These bacteria are doing something physicists thought was impossible, maintaining quantum states in conditions that should destroy them instantly. They're using light in ways that transcend our understanding of what's possible, suggesting that life has access to physics we're only beginning to discover. When we study how memories might be stored in the brain, some researchers are looking at biophoton patterns. The brain emits light that correlates with neural activity, and this light might carry information between neurons in ways that electrical signals alone cannot explain. Memories might be encoded not just in synaptic connections, but in stable patterns of light within neural tissue. Remembering might involve recreating specific biophoton patterns, essentially replaying light from the past. The phenomenon of stimulated emission depletion used in super-resolution microscopy shows us that light can be used to see beyond the diffraction limit that was thought to be fundamental. By using patterns of light to selectively turn fluorescence on and off, scientists can now see structures smaller than the wavelength of light itself. Biology might use similar tricks, using biophotons to detect and process information at scales that seem impossible according to classical optics. Scientists have discovered that water in living cells isn't like bulk water. It's structured, ordered, and it interacts with light differently. This biological water might act as a medium for biophoton transmission, creating optical channels within cells. The water in your body might be more than just a solvent. It might be an active participant in the optical life of your cells, structuring itself to guide and amplify biological light. The study of evolutionary convergence shows that eyes have evolved independently at least 40 times, and bioluminescence has evolved independently at least 50 times. This repeated evolution of optical systems suggests that engaging with light provides such enormous advantages that life finds these solutions again and again. Light detection and production might be as fundamental to life as metabolism or reproduction. Life seems compelled to develop relationships with light, as if drawn by some deep affinity that transcends the specific details of biochemistry. There's a hypothesis that the origin of life might have involved light-driven processes on mineral surfaces, with the first metabolic cycles powered by photochemistry rather than conventional chemistry. In this view, life began as patterns of light-driven reactions that gradually became encapsulated in membranes. We might be descendants of light patterns that learned to build bodies, electromagnetic processes that created matter structures to sustain themselves. Life might be light that learned to persist. The discovery of biomagnetism, the weak magnetic fields produced by living organisms, reveals another aspect of life's electromagnetic nature. These fields are created by electric currents in our bodies, which are intimately connected to light through electromagnetic theory. Your heartbeat creates a magnetic field that extends several feet beyond your body. Your brain's magnetic field, though much weaker, carries information about your thoughts. We are electromagnetic beings, broadcasting our life processes into space as invisible light. When we study how certain bacteria can live on electricity alone, feeding directly on electrons from minerals or electrodes, we see life engaging with electromagnetic energy in its most basic form. These electric bacteria might represent a form of life that predates photosynthesis, directly converting electromagnetic energy into biological processes. They remind us that the distinction between light, electricity, and life might be more fluid than we imagine. The phenomenon of photobiomodulation, where specific wavelengths of light can trigger healing processes in tissue, shows us that our cells are listening to light's frequency. Red and near-infrared light can stimulate mitochondria, accelerate wound healing, and reduce inflammation. It's as if our cells have optical receivers tuned to specific channels, waiting for the right light signals to trigger biological programs. Medicine is just beginning to explore this optical pharmacology, using light as a drug that speaks directly to cellular processes. Scientists studying extremophiles in deep caves have discovered bacteria that seem to use radioactivity as an energy source, converting gamma rays, extremely high-energy light, into biological energy. These organisms are literally feeding on nuclear light, using radiation that would kill most life as their primary energy source. They expand our understanding of life's possible relationships with electromagnetic radiation, showing that life can engage with light across the entire spectrum, from radio waves to gamma rays. The discovery of biological semiconductor properties in proteins like melanin suggests that life might be doing solid-state electronics at the molecular level. These biological semiconductors could be processing information in ways similar to computer chips, but using light instead of electricity. Your body might contain countless molecular computers, optical processors made of protein that compute with photons. The distinction between biology and technology becomes blurred when we look at these molecular machines. There's something beautiful and mysterious about the way light behaves in biological systems, the way it seems to know where to go, how to organize itself, how to carry information in ways that transcend our simple models. Perhaps the scientists who wonder if light might be alive in some sense are touching on something profound. Not that photons have consciousness in the way we do, but that consciousness and light might be more deeply intertwined than we've imagined. Perhaps life is what happens when matter learns to dance with light in just the right way, creating patterns that can maintain and replicate themselves. As you lie there in the darkness, remember that you're never truly in the dark. Your cells are glowing with ultra-weak biophoton emissions. Your atoms are exchanging virtual photons, maintaining the electromagnetic forces that hold you together. Ancient starlight is passing through you right now, carrying information from distant galaxies. You are both a receiver and transmitter of light, part of a cosmic conversation that has been going on since the universe began. The question of whether light is alive might be looking at things backward. Perhaps the better question is whether life is a particularly interesting thing that light does, a pattern that emerges when electromagnetic radiation interacts with matter in just the right way. The boundary between living and non-living, between conscious and unconscious, between light and matter, becomes less clear the deeper we look. We find quantum processes in biological systems that shouldn't exist according to classical physics. We find organisms using light in ways that seem to require a kind of intention, a purpose that emerges from the laws of physics themselves. We find that consciousness might involve light at its most fundamental level, that our thoughts might shine with actual photons, that awareness might be what happens when light organizes itself in particularly complex patterns. Consider the possibility that every photon in the universe is connected to every other photon through the quantum field, that light is essentially one phenomenon manifesting in countless ways. When you see starlight, you're not just receiving energy from a distant sun, you're participating in a universal process, a cosmic computation that has been running since time began. The light from that star connects you to it across impossible distances, making you part of its story and it part of yours. In this view, the universe isn't a collection of separate objects interacting through forces. It's a single process, a vast pattern of light and matter engaged in an eternal dance. The mysteries we've explored tonight, quantum entanglement in photosynthesis, biophoton communications, the possibility of quantum consciousness, these aren't just abstract scientific puzzles, they're hints about the nature of reality itself, suggestions that the universe might be more alive, more aware, more interconnected than we've dared to imagine. The light that physicists study with equations and instruments might be the same light that mystics have spoken of throughout history, the inner light of consciousness, the divine spark, the illumination that comes with understanding. As you drift towards sleep, you might wonder what it means if light is indeed alive in some sense we don't yet understand. It might mean that the universe isn't the cold, mechanical system that classical physics described, but something more organic, more participatory, more responsive to observation and intention. It might mean that consciousness isn't a rare accident in an unconscious cosmos, but a fundamental feature of reality that manifests at many scales, from photons to planets to people. It might mean that we're not alone in a dead universe, but part of a living cosmos that experiences itself through countless forms, with light as the medium of its self-awareness. The photons illuminating this moment have been on incredible journeys. Some left the sun 8 minutes ago, racing through space to bring warmth and illumination to Earth. Others have been traveling for billions of years from distant galaxies, carrying information about the universe's youth. Still others emerged just nanoseconds ago from the quantum vacuum, flickering into existence to mediate the forces between atoms in your body. Each photon is both ancient and new, both particle and wave, both local and universal. They are the universe's way of touching itself, of seeing itself, of knowing itself. Perhaps one day we'll understand what physicists mean when they say light might be alive. Perhaps we'll discover that consciousness is indeed a fundamental property of the universe, that every photon carries a spark of awareness, that the electromagnetic field is the universe's mind-thinking thoughts at the speed of light. Or perhaps we'll find that life and light are even more mysteriously intertwined than we imagine, that the categories of living and non-living are human constructs that don't capture the true nature of reality. The mystery remains, and perhaps that's as it should be. Some questions are more valuable for the wondering than the answering. Tonight, as you drift into sleep, you become part of this mystery. The biophotons in your cells continue their quiet conversations. The quantum processes in your neurons continue their impossible computations. The ancient starlight continues to pass through you, connecting you to the cosmos. You're a pattern of matter and light that has temporarily organized itself into something that can wonder about its own nature, a brief constellation of atoms and photons that can ask whether light is alive. In your wondering, in your consciousness, perhaps light has found a way to examine itself, to question its own nature, to marvel at its own mystery. The scientists who suggest that light might be alive are pointing towards something profound, even if we don't have the language to properly express it yet. They're recognizing that the behavior of light transcends our simple categories, that it shows properties we associate with information processing, with responsiveness, with something approaching awareness. Whether we call it life or something else, there's clearly more to light than we once thought. It's not just illumination or radiation, or waves in the electromagnetic field. It's the universe's way of connecting with itself, of creating relationships across space and time, of enabling the patterns we call matter and life and consciousness. Sleep is approaching now, that gentle darkness where consciousness fades but doesn't disappear entirely. Even in sleep, your brain will emit biophotons. Even in dreams, electromagnetic patterns will flicker through your neural networks. The light within you never stops, never rests, always maintaining the delicate patterns that keep you alive and aware. You're never separate from light, never disconnected from the electromagnetic matrix that pervades all of space. You are light temporarily organized into human form, starlight briefly walking on Earth, ancient photons momentarily arranged into something that can appreciate beauty, feel love, experience wonder. As you settle into sleep's embrace, consider this final thought. If light is indeed alive in some sense, then the universe is far more magical than we imagined. Every sunrise is a greeting from a living cosmos. Every star is a conscious node in a vast network of awareness. Every photon is a messenger in an incomprehensible conversation. And you, in your beautiful temporary complexity, are light's way of experiencing what it's like to be human, to wonder, to doubt, to discover, to sleep and dream. You are the universe's gift to itself, a moment of self-awareness in an eternal dance of light and matter. The soft darkness of sleep calls to you now, but remember, even in the deepest darkness, you're never without light. It flows through you, emanates from you, connects you to everything that has ever been and ever will be. You're woven from light into the fabric of space and time, a bright thread in an infinite tapestry. As consciousness gently fades, as thoughts become dreams, as awareness dissolves into the quantum foam of sleep, you remain part of light's great mystery. Perhaps tomorrow scientists will discover something new about light's nature. Perhaps they'll find evidence that confirms or refutes the idea that light is alive. But tonight, in this moment between waking and sleeping, you can simply rest in the mystery, embraced by the gentle glow of your own biophotons, cradled by the electromagnetic forces that hold your atoms together, connected to the cosmos by the eternal conversation of light. The universe continues its quiet work. Photons race through the void. Stars forge new elements in their cores. Galaxies spiral in their ancient dances. And somewhere in this vast cosmic process, on a small planet orbiting an ordinary star, you close your eyes and drift into sleep, carrying within you the same light that illuminates the cosmos. You're not separate from the universe's mystery. You are its expression, its question, its gentle exploration of what it means to be. In your sleeping and your waking, In your wondering and your knowing, you are light experiencing itself, temporarily, beautifully, as you. And as you drift deeper into sleep, deeper into that space where consciousness touches something larger than itself, perhaps you'll dream of light. Perhaps you'll dream of photons dancing through space, of stars singing electromagnetic songs, of the whole universe glowing with a kind of awareness we don't yet have words for. Perhaps in your dreams, the boundary between you and light will dissolve, and you'll remember what you've always known but forgotten, that you're not a separate being observing light from outside, but light itself, temporarily pretending to be human, playing at separation to experience the joy of connection, the wonder of discovery, the peace of returning home. Sleep now, dear traveller of light. Rest in the glow of your own electromagnetic nature. Dream of photons and possibilities, of quantum mysteries and cosmic connections. Let the light within you settle into patterns of restoration and peace. Tomorrow you'll wake, and light will greet you again, streaming through your windows, activating the photoreceptors in your eyes, triggering the cascade of consciousness that you call your life. But for now, for these precious hours of sleep, you can simply be. A peaceful pattern of light and matter, a gentle expression of the universe's ongoing experiment with awareness, a quiet note in the eternal symphony of electromagnetic radiation that some scientists are beginning to suspect might be alive. The mystery continues, with or without our understanding. Light continues its impossible journey, existing outside of time while creating time for those who observe it. It continues its quantum dance, being both particle and wave, both local and universal, both simple and impossibly complex. And somewhere in that dance, in that eternal flow of photons through space, patterns emerge that we call life, consciousness, love, wonder. We are those patterns, those temporary arrangements of light and matter that can turn back and observe the process that created us. We are light contemplating light, the universe developing eyes to see itself, electromagnetic radiation evolving the capacity to question its own nature. Rest now in that knowledge, in that mystery, in that gentle uncertainty that makes existence so beautiful. You don't need to understand it all. You don't need to solve the puzzle of whether light is alive. You just need to be, to breathe, to sleep, to dream. The light will continue its work, maintaining your molecular structures, carrying information through your neurons, connecting you to the cosmos in ways that transcend understanding. You're safe in light's embrace, held by forces that have been operating since the universe began, cradled by the same physics that builds stars and shapes galaxies. As the final moments of wakefulness slip away, as you cross the threshold into sleep's domain, remember that you are never alone. The light is always with you, not as a separate companion, but as your very essence, the foundation of your being. You are light temporarily organized into human form, and in sleep, you return to a simpler state, a quieter pattern, a gentler engagement with the electromagnetic field that underlies all existence. In this return, in this nightly journey back to simplicity, you touch something eternal, something that connects you to every star, every photon, every conscious being that has ever existed or ever will exist. Sleep peacefully, dear light being. Dream of photons and quantum fields, of biophotons and cosmic connections. Let your consciousness dissolve into the larger light from which it emerged and to which it will return. You are safe, you are home, you are exactly where you need to be. The universe continues its quiet work, light continues its eternal journey, and you continue your dance between form and formlessness, between knowing and mystery, between waking and sleeping. All is well in the electromagnetic cosmos, all is peaceful in the quantum night, and you, precious pattern of light and wonder, can rest now, surrendering to sleep's gentle darkness, knowing that you are and always have been part of light's great mystery, part of the universe's slow awakening to its own luminous nature. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its mysteries gently, peacefully, into the night where dreams and photons dance together in the darkness behind your closed eyelids, where consciousness and light merge in ways that science is only beginning to imagine, where you're both the observer and the observed, the light and the one who sees it, forever and always, until morning comes again. End